Okay, hello, lovely geometry students. Today we are jumping into chapter 12. Woohoo! The last chapter of the school year. And what chapter 12 is all about is it's all about 3D shapes, 3D polygons, also known as what we like to call polyhedrons. So, what's the definition of a polyhedron? Well, a 3D polygon or polyhedron needs three things to it, okay? It needs faces, edges, and vertices. What does that mean? Well, a face would be considered like this trapezoid of this polyhedra would be considered a face of it. The edge is contained here. I'll do that in red. The edge here is where two of the polygons meet together, and then a vertice is where three edges would meet. So those are your basic definitions, and we need all three of these in order to have a polyhedron. Now, some examples or non-examples of polyhedra are going to be something like a prism, okay? Now, this below would be called a rectangular prism because we have a face, a vertice, and an edge. It is indeed polyhedra. Another example would be a pyramid. We have vertices, edges, and faces, so therefore this is also a polyhedra. Now, examples of solids that are not polyhedra. A cylinder. You know, Miss B, why not? Well, I mean, it has faces, okay? It has the circles, but we do not have edges or vertices. So that's a big no. How about the cone? Well, I take that back. The cylinder does have an edge, okay? It just doesn't have vertices. And it's the same with a cone here. I have edge, face, but the vertice needs to be connected by three or more edges, and that's just not the case. No vertice. And then the sphere, there really is no face or edge or vertice, so that's just a plain no, not polyhedra. So when we're classifying solids, okay, we're actually using the base of the solid in order to name it. So for example, this one on the left would be considered a prism. And how we would name it is based on this base down here, which seems to be a pentagon. It's the whole reason we call it a pentagonal prism. What about the one over here? I'll do this one in red. The base of a pyramid is a polygon. Good. So the base is a triangle, and so this would be considered a triangular pyramid. Now, let me explain why. Like, why is one called a prism and one's called a pyramid? Well, this would be considered a pyramid because it just has one base to it, okay? And that one base is a triangle. Now, with a prism, it holds two of these bases or two of the pentagons. So that's why it would be considered a prism. So if I wanted to sketch the following, so a triangular prism, how would I do that? Okay, so if it's a prism, then I need at least two triangles of the same size as my bases, okay? Because as I mentioned with the prism up above, see how this one has two pentagons? So it means we're going to need at least two triangles. And then what I'll do is I'll connect all these vertices together. So maybe connect this one here, and then here, and then here. And that would be a triangular prism. Not too bad. How about a pentagonal prism? Well, we'll just try not to cheat and draw the pentagon from up above. So, well, it's a poor pentagon, but we tried. One pentagon, two pentagon. And then we connect all of the vertices, like so. So I've got here, 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 and here. It's a very poorly drawn pentagonal prism, but it is done. How about a trapezoidal prism? Okay, so I draw two trapezoids, and I connect all the vertices. Trapezoidal prism. Hexagonal prism. Okay, this will be my toughest one yet. 4, 5, 6. A hexagon has 6 sides, so I'm going to draw that. And then we're going to connect all of these vertices here. Here, here, and here. And that would be considered my poorly drawn hexagonal prism. So let's go ahead. I want you to take a couple seconds to determine from left to right if these polygons are indeed prisms or not. So, or excuse me, if these polyhedrons are polyhedrons or not. So are these solids polyhedrons? Say yes or no. Come back, check your answer, and we'll go over in a second. So hopefully you got yes, no, yes. The answer for the left one would be yes, because it's got vertices, it's got this face base on the bottom. Bonus points. Is it a prism or a pyramid? It's a pyramid, just so you know. Okay, so pyramid, vertice, face, and it also has edges, so yes. The middle one here is a no, because it has a face, and it has an edge, but there are no vertices, so that would be a no. And then for the last one, it's a yes, because we've got a face here. This would be considered a prism because we have two of the same bases, an edge and a vertice. So that is a yes. Now, to end on, okay, regular polyhedrons. So a couple more things to know are something like regular polyhedrons. And that's when all of the faces are congruent regular polygons. So this here would be considered a regular convex pyramid or regular convex polyhedron. While this one would be considered not a regular polyhedron or a non-regular concave polyhedron, and that's because all of those sides are not congruent, they are not the same. And of course we've got these two definitions back. We've got convex and concave. So convex meaning that any 2 points on the surface can be connected by a segment inside or on the polyhedra. And what we're really looking for here to see if it's convex or not is really that edge. When it says 2 points, okay, if it can be connected by an edge and that can happen all the way around, that is a convex polyhedra. Now, when it's concave, like this little guy, if I were to choose these 2 points and connect them, there is no way that that's going to be on the polyhedra. So therefore, it is not convex, it is concave. And then our last little story, this is probably my favorite part of the entire chapter, because it's the five platonic solids. And the 5 platonic solids mean a lot to us in many different ways in our geometry world, but I won't get too into it. But it's just important that you know what these are, what they look like, how many faces they have, and so on and so forth. So the first one is called a regular tetrahedron, and that's got 4 faces. You'll notice that these faces are made up of triangles. Our second one is a cube. It's got 6 faces, and you'll notice that all of these are made up of squares. Now, a regular octahedron is number 3. Think of an octahedron as like 2 pyramids just being stacked on top of each other. Okay, you'll notice this top one here, we've got a pyramid looking thing, and then there seems to be one right below it. Okay, the base, technically, if you were to look inside of it, is that square figure, but it is made up of all triangles. And then Miss B's favorite shape of all time is the regular dodecahedron. The dodecahedron, think of like a soccer ball almost, okay? Soccer balls are very much like dodecahedrons because it has 12 faces and it's made up of these pentagons. Now you might be wondering, how the heck can pentagons make up 12-sided figures? And I really want to tell you, but I don't want this video to be too long. So you should just know that a regular dodecahedron is a platonic solid. And then last but not least is a regular icosahedron. That took me a little bit. Icosahedron, which has 20 faces. You might have seen like 20-sided die before if you play D&D. Those are regular icosahedrons. And sometimes like on playgrounds, they have those interesting climby thingies for students, like little kids, to climb up on. I know there's one up in St. Cloud that looks like an icosahedron, and so that is also a platonic solid. So there you go. And ladies and gents, that is it for 12.1. Woohoo! Here's your assignment. Not required, but highly recommended. Thank you so much for your time, and I hope you have a great night.